आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, question says that let a, b, c be three real numbers such that a less than b less than c, f of x is continuous in closed interval a comma c and differentiable in open interval a comma c. Also it is given that f dash x is strictly increasing in open interval a comma c. Then we have to prove this. So we will first write down the conditions that we have given. So we have given that fx is continuous in the interval a comma c, and it is also given that fx is differentiable on the open interval a comma c. Now if fx is continuous in some interval, that is in a closed interval, and if this is given that a is less than b less than c, so we can break this a to c interval from a to b and then from b to c. So the function f of x must also be continuous on a to b interval. Also f of x should be differentiable on the interval from a to c. If it is differentiable throughout the interval a to c and b is lying somewhere in between, that means it must be differentiable at that point also. So this is a to b. So we have get that fx is continuous on closed interval ab and fx is differentiable on open interval ab, and this is what we have the condition of Lagrange mean value theorem. Lagrange mean value theorem, LMVT, says that if there is a function which is continuous on closed interval a comma b, and if this function is differentiable on the interval open interval a comma b. So these are the hypotheses for LMVT. Then there exists, this is the symbol for there exists some element c. There must exist some element in this interval for which the derivative of the function, that is f dash at the point c, should be equals to f of b minus f of a divided by b minus a. This is what Lagrange mean value theorem says. So we have get the conditions for Lagrange mean value theorem for the function f of x. F of x is continuous on closed interval a to b and it is also differentiable on open interval a to b. Then there must exist an element from a to b. So we can't denote it by c. Let's say we denote it by c1. So this c1 should lie from a to b by using LMVT, and for the C1, what happened is f dash C1 should be equals to f of b minus f of a divided by b minus a. So this is the condition that should follow. Let's say we denote it by, we mark it as 1. Now for the other interval, other half interval that we have, since fx is continuous throughout a to c, so it means it must be continuous from b to c. So we can say that f of x is also continuous on b to c and f of x is differentiable on open interval b to c. Then again by the LMVT there exists some c2, let's say, in the interval open interval b to c, such that f dash c2 is f of c minus f of b divided by C minus B, and let's say we mark it as 2. Now, what we have given about f dash in the question. So we have given that f dash x is strictly increasing in the interval, open interval a to c. So f dash x is strictly increasing. That means if f dash x is strictly increasing on a to c, that means if x1 is greater than x2, where x1 and x2 lies in the open interval a comma c. So if we take 2 points from the domain and one point is greater than the other point, and the function that we have given is increasing, that means the function, value of function at the x1 point will be greater than the value of the function at the x2 point. So this is the strictly increasing function algebraically means. So we have given that we have divided the interval a to c as a to b, then from b to c. So that means any point that lies in the interval a to b, that is we have got the point c1. So c1 in the interval, since c1 lies in the interval a to b and c2 lies in the interval b to c, and we have given that a is less than b is less than c. So that means c1 is a point which is less than c2. So we can say that since f dash is increasing, that means f dash c1 should be less than f dash c2. So this is by the condition that f dash is strictly increasing function on the open interval a to c. This is what we have given. Now we will put the values of f dash c1 and f dash c2. So f dash c1 was f of b minus f of a divided by b minus a. This is less than f of c minus f of b divided by f of, this is c minus b. We will multiply it here. This will be c minus b will multiply with f of b minus c minus b will multiply with f of a, and this is less than, also multiply this b minus a with f of c minus b minus a multiply with f of b. So now take all the values in the LHS. So this is c minus b, this is b minus a. So c minus b, and we have f of b. So we can take c minus b and this will become plus b minus a. We can take f of b common from both the terms, and this will become addition when it comes to LHS. So this is minus, we can multiply it throughout the bracket. So this will become plus b minus c f of a, and this is when it comes to the LHS, that will become minus of b minus a f of c less than 0. So final answer that we will have, this will be c minus a times f of b plus b minus c times f of a, and on multiplying this minus, this will become a minus b times f of c less than 0. And this is what we need to prove in the question. So we have proved the same here. So this is the answer. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।